everyone. Let me start maybe from the beginning. So today's OVP webinar relates to OADP. So it's a new API that's appeared in the OpenShift environment. And today I have Jarek with Jarek from Red Hat. So Jarek, if you could introduce yourself.
Yeah, so hello everyone. My name is Jarek or Jarosław. I work for Red Hat for almost 10 years as a solution architect, and I'm focusing mostly nowadays on Red Hat hybrid cloud solutions, which more or less includes everything what is related to OpenShift container platform, which can be deployed across on-prem and different clouds, public clouds.
And my name is Marcin Kubacki. I'm Chief Software Architect. My background is virtualization, infrastructure in general, but also the software development. Actually, OADP is quite important topic to us because Storware as the company actually develops one of the solutions using OADP APIs. So maybe let's start, Jarek, with a brief overview of different methods of data protection in OCP.
Yeah, so depending on what are your requirements, what are your service level objectives, there are a number of solutions that are available in OpenShift to protect and ensure the availability of the applications that will meet your requirements. Yeah? So as you can see on the picture, there are three major types of solutions. Of course, today we focus on backups, which are in general a solution to protect us from some logical failures that may happen if somebody by mistake or by some accident will delete or remove some data. There are also other types of solution in OpenShift which probably are good topic for other meeting, which can protect us from either the hardware failure. So if we lose some server, some physical server that is part of our OpenShift environment, and we have also other solutions that protects us from the whole site disaster. So when we lose connection or there is some accident that causes the failure of the whole site.
Okay, so how does the OADP fit into the overall architecture? How does the general architecture looks like for the OADP maybe?
Yeah, so OADP as majority of functionalities in OpenShift is developed and is provided as a operator. So you install OADP operator on OpenShift, and this operator enables the APIs that can be used to backup and restore your applications. This includes both the application configuration, so all the Kubernetes manifests, as well as the per system volumes, where you can store data or the state of your stateful applications. So OADP itself provides an API, so it is quite, I would say, low level. Hence, it's the best way to use it is to use one of the integrated and supported backup platforms that allows us to implement the complete backup and restore workflows. And here, of course, one of the options you have, one of the best options is the Storware solution. Now going to the bottom, yes, we have, as I mentioned, we can backup not only the application configuration Kubernetes manifest, but also the persistent data, and this data can be stored on many different persistent volume platforms. So this could be either our own Red Hat OpenShift Data Foundation solution based on the Ceph storage, software-defined storage technology. You could also use some other storage solutions which can be integrated with OpenShift either using the standard CSI container storage interface drivers, or maybe integrated using some other, let's say, legacy methods. And specifically for the CSI, the OADP also gives a possibility to leverage the CSI snapshot, so that you can execute or take the snapshot of your persistent volume. And we also provide optional tool that can be used to copy these snapshots to some external storage, so that we have a full copy of the data outside of our cluster.
Okay, so that was high level, and maybe if you could share more details, how does it work internally?
Yeah, so in general, we didn't want to maybe reinvent the wheel, but we wanted to leverage the best solutions that are developed by open source communities. And in this case, of course, one of the famous solution, most complete solution in this area is Velero. So basically, Velero is also a foundation for OADP. But of course, in order to use it easily in OpenShift, we have developed the operator itself. We have also developed a plugin for Velero to integrate with the CSI storage drivers. And also we created a tool data mover I mentioned that can be used to move the data, move the snapshots, CSI snapshots, to some external backup. But really the core of the API that is exposed is based on the Velero API. So you will see during the demo that after the operator is installed and configured, the let's say daily backup and restore operations are based on the APIs that are exposed by Velero itself.
So now actually we can go to the Storware part. As you have noticed, the third-party piece in the previous architecture is the independent software vendor. So Storware is one of such companies. And Storware Backup and Recovery, to give you a general overview, is not only able to protect OpenShift. Obviously, OpenShift is one of the several sources that we support, as you can see, and we have integrated it on the OADP layer. So Storware Backup and Recovery supports also many different backup destinations. So if you backup anything in the OpenShift, in this case, you can store later these backups in the file system, object storage, maybe some other enterprise-grade backup providers, and that is quite transparent. So it doesn't really, you don't have to connect them in any way into the OpenShift platform itself. The multi-node architecture allows us also to scale. So if you have bigger environments, we don't have any limitation in this case in terms of the single node that you need to scale up. You can add more nodes if necessary, and all of them will be, obviously, the workload is going to be distributed. And the brief summary of how it works with OADP looks like this. So OADP in this case is being used for the metadata handling, because the new API actually solves many issues related to all of these different artifacts that are being stored and exported during the backup. However, the actual volumes are being snapshotted using CSI snapshots, so the official interface for snapshots. If snapshot is going to be a result, so if during this operation we are able to see the snapshot, it means that we have a crash consistent backup. If not, because some CSI drivers, they don't support snapshots, strictly speaking, we will have a backup on the file level, usually for file level volumes. Optionally, we have also the Ceph RBD support. So if you have it's connected rather not via the storage class, but per volume. Optionally, you could have direct Ceph RBD connected to your deployments. Technically, we also are able to support incremental backups using the snapshot difference APIs on the Ceph. So that's how usually it works. And for file level recovery, also in such scenario would be possible. Very important question that we also receive is that if we require sidecar pods, so technically we don't require any pod being attached to your deployment, so no deployment modification needed. However, we will provision dynamically sort of sidecar pods, helper pod, which is able to connect to these PVs and dump the data during the actual backup process. Okay, I think now we can go with the demo. So let's start maybe with the OADP.
Yes. So this is a good time to start demo. I will start with the OADP. Just let me switch the screen. So here I have OpenShift cluster. In the OpenShift web console. I will use it for a demo today. Of course, as you might know, everything you can do in web console can be also done using the command line interface. So in order to use the OADP, you have to install the operator. So I already did it, but just to show you, here you can see we have OADP official Red Hat operator, which is part of the OpenShift, fully supported, of course. And we have also the community upstream version of the OAD operator that is developed by the community and is the upstream for our operator. So once you install the operator in the dedicated namespace, you have to configure it. So you have to basically configure the instance of Velero and also optionally Restic if you would like to use it for file system backups. So this requires to create a YAML file following the documentation. The key part is really the Velero configuration, especially the storage. So you have to configure where the backups will be stored. So this requires some S3 storage. In this my example, I'm using the Red Hat ODF S3 storage, so based on the Nuba operator. So after you create this file, configuration file for the operator, this will trigger the provisioning of the Velero instance as well as the Restic pods running as a daemon set on every worker node in your cluster. That's how Restic works. So it needs to be installed locally on the node in order to have access to the file system of the persistent volume that you want to backup. And now it is ready to backup and restore data. So if we want to create a backup, we have Velero API backup object that needs to be created in order to start a backup. So now I will create one. I hope I save it. Yes, I have it in my. So you can see here the structure is very basic. So what you have to specify here, you have to decide if you want to use Restic as a to take persistent volumes backups. If you say no, by default it will use the CSI snapshots if they are available in the storage that you use to create your persistent volumes. You have to specify namespaces of the projects that you want to be backup. You have to specify the storage location, which corresponds to the configuration that was created in the previous step, and the TTL, so how long the backup will be kept by the platform. And basically that's it. We start the process, and it will now execute the backup. So we have to wait for some time. So for the demo, I created an application. Let me just briefly show it to you. So this application consists of two pods. So we have a MongoDB, which basically has a persistent volume created here. So we should, if we scroll down, we can see here that there is a persistent volume claim created and the persistent volume where we store a database data. Also, there is a second pod that runs some sort of REST API that allows us to access the data from the database. Of course, there are some other objects like deployment, like networking, so the service and the routes. Yeah, so fully functional application. We can now also check that it is running. So let me just so here you can see it return some data. Maybe in raw format you can see it gives me some JSON documents. Yeah, so we have some data that is stored. Okay, so let's come back to OpenShift. We can check if the backup has been successfully executed. Let me just come back to the ADP project. And here we have the backups. Yes, so a lot of them. Let me just sort them, maybe not by label, but I would prefer by name. And here on the bottom, I think is the backup that has been created just moments ago. Yeah, we can see when it is created. We can see also when it expires. So I will make a copy of this name because I will need it to restore to it in the restore procedure. Okay, so we have a backup. So now we can do the worst thing that can happen to us. So we will delete the project completely. So we are going to lose everything. This includes the application data as well as the whole configuration. So it will take some time to terminate the project. In the meantime, let me just quickly prepare a restore object. I will just copy it and will explain you in a minute. Okay, so I'm back here. The project is gone. We can now call the API. You can see we have the response from the ingress router that there is no service available anymore. So we have lost everything, and now we can create create a restore object. Oops, sorry. Yeah, so the restore object again. Yeah, just need to probably remove. Okay, so the restore object again, standard Velero API. I need here just provide a reference to the backup object that I have created before. So basically, I can restore from any backup that is present in my environment. So I create it. It starts automatically thanks to the operator, OADP operator, and we can now watch how this application will be restored. So we will see here in a hopefully couple of seconds the project that will be created. And yeah, so we can see now the project is here again. And we can also now watch the pods, but need to switch to the right project. So we can see the database. It will take some time because it also needs to provision persistent volume. Then it needs to import the data to the file system, and finally the both pods are up and running again. And we can check now with the CLI. Let me just clean it. Clear, sorry. And again, the same command. You can see that the same data set is again present. So everything has been successfully restored. So these are, of course, the two most, let's say, straightforward configurations and objects that we will use, so we can create on-demand backups and restores. But you can see here on the top that there are much more objects here, configuration objects that the operator provides. Most of them will be not used by yourself directly, because they are mostly some, let's say, sub objects that are related to the backup OADP configuration. But the one I just wanted to mention, which also is somehow connected with the full backup solution, is the schedule. Yeah, so you can also create a schedule where you can basically, using the cron tab syntax, define when the backups should be created, how long the backups will be valid. So you can see I have this configuration here. And if we now come back to the backup list, we can see that these backups are executed. So basically, those backups here with the date as a suffix in the name, these are the backups that are created using this scheduler. So these are the functionalities that are provided by the OADP. So you can see is kind of low level, and in most cases you should have some on top, let's say, enterprise backup solution that will really manage this backup and restore workflows using the whole solution. And this will be, I think, the good time for Marcin to go ahead with his demo. I just need to
now we should be able to switch
screen sharing,
to
yes.
to my screen.
Okay.
Okay, so let's start with simple login. So this time we are looking from slightly different perspective. We are logging into the web user interface of the Storware Backup and Recovery. And from Storware Backup and Recovery perspective, this is treated as the virtual, and deployment corresponds to the specific virtual environment. So deployment is going to be an entity that we protect in this case. In the infrastructure tab, you see that I have Red Hat OpenShift attached already, and inventory synchronization process usually collects all of this information around the projects that are there, the deployments that are in these projects. You can optionally assign quotas per project. So if you don't want backups being invoked for the deployments in specific projects more often, it means that I can, let's say, have a hard limit, no more than 5 backups during the 24-hour period of time. I can later assign it to the individual project and limit that. Now, the instances that I see in here, I can filter out, let's say that I'm interested only in the OpenShift right now, and I can initiate some backups. So by default, it's full, as I mentioned, incremental backups, at least for now. There is no generic approach that we have implemented already for the OpenStack, but it is coming as well. So only for Ceph RBD volumes, as the exception, it is supported. But in general, it is both for file-based and block-based volumes that you can mount inside your deployments. At the bottom of the screen, you will see the backup process running. So this actually is going to invoke the export phase. Export means that we are fetching data from these containers, from these persistent volumes, and store it in the staging space, while later we are pushing it to some S3 file system, enterprise-grade backup providers, you name it. So all of them can be seen here in the backup destinations. And you can create multiple backup destinations, which you later refer in your policies. So while the backup is running, a short overview of other things. So definitely policies. We have talked here about the scheduling in the main OADP. However, there is a built-in scheduling mechanism in here. So you define a policies, and inside each of these policies, you have rules. Rules, strictly speaking, define all of these aspects, like where the backup should be stored. Optionally, you can have secondary storage as well. How long these backups should be stored, so for how many days or how many versions, and according to which schedules you would like to execute such backups. Multiple rules means that they can work according to the separate schedules. So you can have, let's say, monthly backup, for instance, being stored in the S3, but daily backups should be stored in your regular file system, for instance. And virtual environments tab allows you to specify which deployments you are interested in, actually. Automatic assignment, so you don't have to think about this, that new deployments appear every day. You can automatically assign them based on the naming convention or labels in the OpenShift environment. Assign only maybe to the policies if the deployment doesn't have policy assigned yet, or automatically remove them if no longer this specific deployment matches your requirements. For instance, somebody has removed label like backup true from your deployment, and it means, strictly speaking, then during next inventory synchronization, it would be automatically detached, removed from the policy. File level recovery. This is so whenever we have the backup and restore capabilities, like regular restore coming, let's say, from the main list here. So typically you could restore directly to your hypervisor or file system. Let's say file system means that you would like to play with the artifacts that we have protected. So your volumes, your metadata, for any reason. Restore to hypervisor actually would allow you to restore a new deployment back to that given namespace, like the project name in this case. This one is actually for Kubernetes, but if we filter out other instance like this one is for the OpenShift. You would be able to specify projects, specify the storage mapping. For instance, if you have different storage classes, you may be interested in temporarily restore it to the, let's say, bronze storage class instead of the fast one, just for test, let's say, or advanced settings if you would like to, let's say, override such environment. So we also have the recovery plan options. So if you have a batch restores, if you would like to specify that periodically some restores are going to happen, then you have the recovery plan options where you can, on demand or by schedule, define rules that, let's say, OpenShift, and this is obviously per specific type of the hypervisors, so that the restore parameters are consistent. So all of the deployments from this list, according to these schedules, optionally, will be restored with these settings. So last successful backup, or maybe last regardless of status, if you wish explicitly the restore to fail, to have that in your report, for instance, just for test purposes. So in general, we cover wide range of sources, wide range of targets, and OADP is used here to provide you the consistent backup of your application. If that's not enough, you also have the application generic mechanism to protect your applications inside the cluster. So you can use basically any arbitrarily scripted or native command for your application. You also are able to use the predefined templates. One of them includes the etcd database, if you wish to also have that in a single place, being reported under a single dashboard. Okay, so I think that concludes the demo, and now let's maybe switch to the Q&A session. So let's ask questions either in the questions tab or in the chat.
It's like everything was crystal clear.
Okay, I don't see any questions in here. Nothing in the chat. One of the aspects that we also want to cover in the next releases is OpenShift virtualization. So this is something which has also recently appeared in the OpenShift, and virtual machines will definitely store more and more data in these persistent volumes. So we see that more workloads are coming to the OpenShift world. And regardless of what type of the deployments you are using, actually with Storware backup and recovery, we are going to cover that as well. At this point, I don't see any questions. So thank you for today's webinar. If you have any questions, you can always ask us. You can track us on the YouTube as well. And thank you for watching, for staying with us during this webinar, and stay tuned for the other webinars. Bye.
Bye.